Hai and Assalamualaikum. My name is NURAINA binti AHMAD RUZI, and I'm going to share about my final year project, which is the topic is the simulation of factors that affected gas blowout during offshore soil boring activity using ANSYS software. This study focused on the simulation of the early detection parameters to avoid a gas blowout accidents. It has been done using ANSYS Fluent software, whereas the method used is the volume of fluid. The main objective is to simulate the parameters affecting the gas blowout during offshore soil boring activity. The parameters studied are the bubble gas surfacing time at the specific height and the behavior of bubble distribution. This simulation showed that a shorter bubble gas surfacing time if the inflow rate is high. The bubble distribution behavior is also studied, which the gas blowout may occur if there is a gas kick in the well as the bubble distribution rapidly escape from the well. Finally, early detection can be made from the bubble gas surfacing time and the behavior of bubble distribution so that the drilling process can be stopped and the drilling rig can be pulled out to shut down the oil exploration. The problem statement is a well gas blowout is a fatal accident that occurred during oil exploration. So this accident may lead to a fire and explosion occur at the vessel or wellhead. However, this research is still ongoing as the accidents are still affected randomly by the surroundings. The simulation of computational fluid dynamics has been used, which is the technology to prevent any harmful accidents. So this is the method I used to simulate this research. So basically, this flow chart for the ANSYS. So for the first one is the generate geometry, generate mesh, setup and solution, and we will get the result. So the method I have used is volume of fluid, and there is assumption that I have been made, which is the simulate will be simulated in one currency, which is the lack of features of the software, and also in complex. So the next assumption is multi-phase, which is it runs in the steady state. So this is the main result. We can see here the graph of gas surfacing time decreasing with the increases of the flow rate of the released bubble gas. And the next figures is the gas surfacing time of different bubble release at different flow rates. As we can see from the graph, the release rate from 0.1 to 40 does not show any significant changes of time. Hence, it is still mentioned to be the safe stage for the drilling process. Apart from that, the release rate of bubble gas start from 60 is started to show the most changes as its bubble gas surfacing time is almost 30 seconds. As a conclusion, the bubble gas release rate in between 60 to 100 meter cube per second shows the leading to the major gas kick and the well blowout may be occurred. At the flow rate of 100 meter cube per second, the graph shows rapidly decreasing as it proves that it led to a major gas kick. Okay, from the figure, the first figure is the which is the safest bubble release at the 0.1 meter cube per second. Behavior of bubble distribution shown here is the safe stage for the drilling process. So the second figure is the bubble release at 60 meter cube per second, which is the bubble distribution for the gas kick that can lead to a major gas kick. This is because shell density normally increases with depth but decreases when drilling in anomalous pressure zones continuous at this pace. The next figure is bubble release at 160 meter cube per second. At this rate, it shows the bubbles start to split into two at certain height. Theoretically, the increasing bubble escape from the well due to the high flow rates. It may occur a major gas kick in the well and the drilling penetration should be reduced or stopped. The last figure at bubble release of 360 meter cube per second, which is the bubble does not split anymore. Based on the Stokes law, As the decreasing of bubble diameter, the pressure inside the bubble in the water are increasing. Hence, the rising speed of bubble in water per second also increasing. So as a conclusion, the increasing of the inflow rate of the bubble gas led to the shorter time of the bubble gas rising up. As an early detection of the gas kick, if the bubble distribution start to rise up faster and rapidly, the drilling should be stopped. As from my simulation, it can be observed in only 1 meter height before the bubble will be dissolved fully. So as some recommendations, in order to apply this simulation to the real world or real situation, the validation must be done using some experiments. Other than that, for a better result, a further simulation can be made using different sea current, as there is a different density, temperature and salinity at different height under the sea level. So that's all from me. Thank you.